Hi, I'm Alex Dempsey. For the last 4 years, I've led engineering for our archiving and data services group in our archive. It's such a privilege to be in the business of preserving knowledge, culture, and history, and to be amongst all of you who are doing the same. I'm going to do a little primer on what, my talk, Better Together, building a scalable web archiving toolkit. I'm going to look at how we do large crawls or domain harvests, where we'll work with a partner to get an entire country's web captured. I'll do a primer on what these look like, talk about some lessons learned, some of the challenges, and then close with some of those takeaways and open up for Q&A. So large-scale crawls or domain harvests, they have different trade-offs from, say, you want to lovingly preserve this one web page in all of its fullness. We're not able to do that because we're trying to get everything. So we're willing to sacrifice some things for the sake of efficiency. So the architecture I'm going to share isn't necessarily the right thing for every kind of crawling that you want to do. No single tool has the capability to collect everything. So collaboration and using different open source projects is key. And we've been doing this for 25 years, large-scale crawling, so I'll share some lessons of that, and I'm going to illustrate a scalable architecture for this. But first, some more context. This is our headquarters in San Francisco. It's an old church. Randomly, it was my dad's church, and so it's very weird that I work in this building now. It's also a data center, which is weird, and I think as a technologist, I have the uncomfortable position of defending the old. I think some of the old ways of doing things are good. And some of the architecture of Heritrix is actually very nice for this kind of work. There's something about this building and another data center we have not far away in the city of Richmond, which is an old warehouse. So they weren't originally designed to be data centers. So there's no battery backups, there's no HVAC, the machines are filled with dust. There's no cooling. So on a hot day in California, doom, one of these things can drop offline. And we've just lost half of our infrastructure. But it's okay, because we have to keep 2 copies of everything anyway. So we've got the church. The church is still up. So that's online. We're in read-only mode. But it does mean that we have to design everything to be as resilient to network partition, power loss, or other things of running your own infrastructure as possible. On the plus side, it's really cheap. And we use a fraction of the electricity of a commercial data center. So without increasing our electrical or thermal envelope year after year, we're able to grow 25% every year. And we're able to add 100 terabytes every single day, because we're taking all that savings and we're throwing it into hard drives. So that part's good. So kind of like what is a domain crawl, large-scale crawl? So imagine we're going to take a country's entire ccTLD. And maybe we're going to get 1 billion URLs in this crawl and about 80 terabytes of compressed content within. We do these in 6-week iterations. We want to get breadth and depth of diverse content, news sites, government pages. There's a lot of those disappearing in the United States right now. I'd like to catch those. And multimedia-heavy platforms. We start with the foundation of Heritrix, but we adapt and we bring other tools in to be able to get some of the challenges solved or addressed or mitigated. A large crawl lifecycle looks like this. We have a week of prep where we take all of the input seeds for the crawl. We clean those. It's very important to look at those first. You can't get it all. Then we run a test crawl for about a week where we try it. Is there something new we want to try for this harvest? We'll try that in the test crawl. And if all goes, maybe we go, oh crap, there's a new kind of trap that we have to do some mitigation. When that's all done, we move into production. That can last for anywhere from 4 to 8 weeks. And then we do a patch crawl at the end where we get so much stuff, you can't get the whole infinite graph, but you have all these URLs from the frontier, and we have this big data Hadoop cluster where we toss all those things in and get a prioritized list of things that we're going to get in another week of crawling. The anatomy of a crawl. First, you have crawlers, and we're going to feature Heritrix here, but there's other technologies. And a crawler has to start somewhere. Those somewheres are the seed URLs, and that's the URL for the home page of a site. But it doesn't have to be, but it's usually that. The crawler is going to download that page. It's going to run something called an extractor, looking in that page. Give me some more URLs to go fetch. As it fetches all those URLs move up into the frontier. Then the crawler goes, great, frontier, give me another URL. And I'm going to keep doing that and recurse. And you start growing a crawl tree until you hit scopes and limits. Like, we only want so much of this domain. We only want so much of this domain. This domain, we don't want any videos, things like that. And finally, of course, all those documents are saved into web archive files. I'm sure so many of you know this so much, but for those of you in the audience who are not crawl practitioners, just a little bit of a primer. So now it's for some challenges. In the beginning of the web, this is what the world looked like to a crawler. We have like a couple URLs, cats.com, spacejam.com, sweet. We have an image, GeoCities, under construction GIF, very great. Heritrix could download this HTML, parse out the URLs, so fast, so clean. That thing could just rip. But then over time, we saw more of these things. So video, super JavaScript-dominated web pages, popularized React, and all kinds of different spam. And the spam is kind of like a catch-all for all kinds of browser traps, crawler traps. And of course, things just got bigger and bigger and bigger and bigger. We have like a little display at our office that is the World Wide Web in 1997 in 73 inches. And it has like a bunch of old CRT monitors, and like you could fit the web in that then. That's not true now. So yeah, scale and speed, web growth, these are constant challenges for us. And yeah, dynamic media, JavaScript, crawler traps, and efficient storage management and avoiding redundant data. So doing deduplication is very important. So some lessons learned: set clear scope and limits. You can't get it all. Start with cleaning the seed inputs. And so we do something there. We tokenize all the URLs for the seeds, and we look for patterns in those for things that you can remove. And conduct test crawls. You got to distribute the workloads across multiple machines to enhance the throughput and efficiency. And I'll talk a little bit more about that in a bit. You got to set crawl limits. And ethical etiquette is very important. Be nice, AI crawlers, for the love of God. Like, so Heritrix is designed to be nice to the sites that we crawl. And we say who we are when we do this stuff. And we have a URL, and they're like, hey, you want to learn more about why we're crawling? You click this link and contact us if you have a problem. And sometimes people contact us, and we work something out. We implement deduplication to reduce redundant storage, and it's similar to how Marius was talking about hashing a document, checking in a database. You already have that. And I'll talk a little bit more about the multi-machine crawling setup in a second. And the patch crawls I mentioned, we have something called a web archive transform file, where we already have all these works. And one of the things we give to our partners are these, if they want them, are these WAT files. And they have like all of the outlinks from a page. And again, we feed that into a Hadoop cluster to do like a sort of, not quite PageRank thing to figure out what are the remaining URLs that we would like to target in another week of patch crawling. Let's get into some specifics. So the first thing, and I think the most important part about making this whole system scalable, is the simplicity. And the core piece of that is you want each crawler to not be aware of the other crawler. So Heritrix, each one is like a self-contained system. And it sounds fancy, we organize the crawlers. So say maybe we're going to use 10 machines for this crawl, and each machine has its own local hard drive on that machine. So it's not using network storage. And we organize them in a hash ring, and it's a fun thing. You don't really need to know the details, but suffice to say that each crawler knows which seed URLs belong to it, and it knows which seed URLs belong to the other crawlers without having to have a full list of all the seed URLs. So it doesn't take a lot of memory, and it's really quick to tell. And as each crawler is doing its thing, most of the documents you're going to download from a website are from that website, so that one machine is able to do its full job, keep its own dedupe history, keep its own I've seen this check all locally, and it doesn't have to contact another like big, bad central database that's like going to be hard to maintain. So this is like almost endlessly scalable. Of course, not every URL is going to be from the same thing that's in your part of the hash ring. So we bucket these, we log when we find these things into like big chunks, and then periodically we send that chunk to the machine that it belongs to. And that machine knows, I locally know whether it is in scope for me or not, or I've already gotten it. And if there's anything I still want, I put it into my local frontier. Next challenge, dealing with JavaScript. So we have two approaches for this. So we also developed a crawler called Browsler, which is a browser-based web crawler. It works great. We also have Heritrix. That's one way of doing it. And something newer that we've been trying to do for our larger scale crawls is dusting off an old idea that was called Umbra, but we have a new one called Penumbra, where we do browser assistance with Heritrix. The downside of the two different technology approach is that each one has its own brain, and now you have sort of a split brain situation. Each one's like, I am in charge of dedupe, I'm in charge of scoping, I have my own reporting, and you either go like, well, I'm gonna just deal with that, or you build a third master brain that's aware of both of them, and we've built one of those, and it's like, okay, cool, but it'd be really great if you only had to use one. So the Penumbra approach, you have Heritrix is the only thing with a brain, and it says, I want to do an extraction. You fetch a page, you do extraction. I want to use a browser to do this extraction of URLs. So I'm going to say example.org, RabbitMQ, here's that. It's a big queue, and it's very boring and easy to run. And then Penumbra is listening on that queue, and it's going to run that page in a Chrome browser using an open source tool called Playwright. And Penumbra is just 500 lines of code, wrapping Playwright, written by Microsoft. And I'll talk about that more in a second. And it's going to intercept all of the URLs that the browser called while loading that page, take those URLs, tell RabbitMQ about them, and then that is going to go to the Heritrix machine that requested it, and it's going to then decide, is this in scope? Do I need to deduplicate this? If not, put it in the frontier and crawl it. And this has been great. Like with Penumbra, we've been able to, it's 10, 20 times faster than our previous work on using Umbra. It's not as high quality of capture, but it's much better than stock Heritrix. And because it's so much faster, we could apply this to much, much larger portions of a domain harvest. Playwright is written by Microsoft. It supports a bunch of different browsers. They made it so that they could get developers to test their websites on their browser, Edge. And it supports TypeScript, JavaScript, Python, .NET, and Java. They're doing a ton of work. Like when you install Playwright, you just pip install Playwright. It will then fetch the browsers for you. You don't have to manage figuring out how to install all those. It will control the browsers and has a nice high-level language for controlling a browser. Next challenge, collecting rich media assets. So if you just have a browser that's like, or like a crawler that's waiting for video files coming in, checking the time. Probably good. Anyways, we use YTDLP for this. It makes it a lot better. YTDLP is an open source project. It has over 1,400 contributors from all over the world. And they have written extractors for thousands of websites, finding the embedded videos there. We could not develop this ourselves. And what's really cool is that the architecture of Heritrix, it's all just, I've got a page, what extractors do I need to run this on? And you could farm it out onto a queue to get extractions done on that, put them back into Heritrix, you have one brain that runs the whole thing. So takeaways. Running a data center in a warehouse sounds quirky, but it fits the mission. Like this data by definition is like archival data. It's not necessarily the most valuable thing that needs to be on the triple redundant SSD everything. Like we could build, there should be 1,000 old churches that have, have a few racks of machines in them, and you could just get lots and lots and lots more stuff for not a lot of money. The cloud is very, very expensive. If we did what we do in the cloud, it would never, ever work. The key to scalability is limiting coordination between machines. Each one of our machines is basically a world unto itself, and we still get pretty much the full benefit of deduplication as if we had like one big master database that we had to operate for these domain crawls. Heritrix's battle-tested and extensible design still has legs. It won't be forever, but right now it still works, and using the Penumbra technique, we could do more for this wide-scale crawling, and that's very nice. And leveraging open source advancements is key. Microsoft is doing a lot of great work for us that they didn't intend to, and we don't have to replicate that work. YTDLP is doing a lot of great work for us. We don't have to replicate that work. And there's going to be more and more other tools that come up from other teams that we can integrate using that architecture. So with that, thank you. If you have questions, hit me up.